Hello everyone. Today I'm going to explain how to operate the switch in the distribution room and the correct sequence for powering off our capacitor cabinet. When we power on, we need to follow a specific order. First, we turn on the capacitor cabinet, and then we turn on the load switches of the various groups of outgoing cabinets at the back of the power cabinet. When we power off, we must follow a different sequence. First, we turn off the capacitor, then we turn off the load switches of the outgoing cabinets to shut off the loads, and finally, we pause the incoming cabinet. Once the incoming cabinet is cleared, we can safely turn off the transformer cabinet in front of the transformer. By following these steps, we ensure a smooth and safe power on-off process. Speaking of power on, the sequence is reversed. We first turn on the high voltage switch of the transformer cabinet in front of the transformer, then we turn on the incoming cabinet, and finally, we turn on the load switches of the outgoing cabinet. Last but not least, we turn on the capacitor cabinet. This sequence ensures that power is properly distributed and prevents any potential issues during the power on process. Now, why do we need to turn off the capacitor cabinet first during power off? Well, most of our power cabinets are smart and equipped with automatic compensation functions, which can compensate for the required capacitance automatically. As a result, if we don't follow the correct sequence, the cabinets can still compensate on their own. However, if the automatic compensation function fails, turning off the load switches of the outgoing cabinets before turning off the capacitor cabinet can result in overcompensation and cause harm to our system equipment, especially if there are harmonics present. Overcompensation leads to excessive harmonic current, which can potentially damage the equipment. Additionally, after overcompensation, there's a risk of overvoltage for the remaining loads. Overcompensation raises the voltage, which can adversely affect the electrical devices and even cause damage. That's why it's crucial to prioritize turning off the capacitor cabinet first during power off. Power factor is another important consideration. It refers to the ratio of active power to apparent power in an electrical system. Our power supply department pays close attention to power factor assessment. Under normal circumstances, the power factor should be between 0.94 and 0.99. If it falls below 0.85, fines will be imposed, while a power factor above 0.85 will result in rewards. Which will be reflected in our monthly electricity bill. Beyond the power factor, we also need to regularly inspect the capacitor cabinet. We should ensure that the ambient temperature does not exceed 40 degrees Celsius and the temperature of the capacitor's shell does not exceed 60 degrees Celsius. We can use a thermal imaging gun to measure these temperatures accurately. Additionally, we need to pay attention to any discharge sounds, signs of faults, and check for any damage to the bushing insulators. Furthermore, it is necessary to maintain a voltage in the power grid below the rated voltage of the capacitor cabinet, and the three-phase voltage should be balanced, with no more than a 10% difference between phases. Lastly, when it comes to voltage transformers, if they are unloaded and there is no load, our capacitor cabinet must be self-started to avoid overcompensation and resonance. Before closing the switch of the capacitor bank, we must ensure a discharge time of at least 3 minutes. By following these guidelines and ensuring proper operation and maintenance of the capacitor cabinet, we can effectively manage power distribution, prevent potential issues, and ensure the stability and reliability of our electrical system.